Today's lecture is chapter 3, plate tectonics. Plate tectonics is the base of the study of earthquakes. If you need to study earthquakes, you need to study first plate tectonics. What is plate? Plate is shariha in Arabic. It deals with the surface, the crust of the earth. The crust of the earth is not one piece. It is pieces next to each other, but very, very big pieces. One piece may take, Africa is in one piece. Imagine that all of Africa is just one piece of these plates. So you have plates next to each other. These plates, as I said, are not connected, they are just close to each other. So if there is a relative movement between them, if one of the plates move, then there is a problem. And here, this is what we call in Arabic fawaliq, or in English faults. Faults is the gap between plates or cracks within the plate. These gaps or cracks means that there may be a relative movement between two things. Imagine that you are standing on the ground, one leg is on a rock and another leg is on another rock, and one of these two rocks started to move. You will fall. So this is really what happens to buildings. If I have a building and beneath this building there is a crack or there is a fault, then there is a very, very big possibility that this building would fall. Why? Because there will be a relative movement within this building. Part of the building will move with the first part of the rock, and the rest of the building will move in another direction with the other part. So the building will be split into pieces and it will be shattered down. It will fall down. So this is what we are going to study in chapter 3, plate tectonics. Just to say what we have studied before, in chapter 2 we took introduction to engineering geology. In chapter 1 we took introduction to geotechnical engineering. So after these two lectures, we knew why we are studying engineering geology. So starting from chapter 3, we are now studying what we need from engineering geology. Part by each lecture, we are going to study a special subject. Just a reminder, this is the shape of the earth, and as we said, the shape of the earth, the outer layer is called the crust. Then we have a lithosphere, a xenosphere. We have just discussed this. This is related to the crust. And then we go deeper to the mantle. We have upper mantle and lower mantle. Then we go deeper to the core. We have a liquid outer core and a solid inner core. And we said that the inner core is the hottest part of the earth, and the temperature is similar to that of the sun. So here the temperature is nearly the temperature of the sun, and here at the poles you may have a degree of less than 0. So it means that there should be some kind of cooling system within the layers so that the temperature would change from thousands of degrees to minus degrees. There is something that we need to discuss. It's called geomorphic process. What is the geomorphic process? Geomorphic processes are the forces that shape the earth. Was the earth the same millions of years ago? No, it was completely different. The shape of the earth is different. How this happened, we will see in this lecture. So, who shaped this Of course, we know who should. God shaped the earth, but using what? What are the tools that shaped this earth? There are two kinds of forces that affected the surface of the earth, or the earth as a whole, and shaped it. These are called endogenic forces or exogenic forces. Endogenic, from the name, endo in English, in Latin, it means internal. Exo means external. So some of the forces that affected the earth are internal forces. So it means that originates from the inside of the earth. And some of the forces are exogenic forces. So it comes from the atmosphere, from outside, but it affects the shape of the earth. Let's take the endogenic. The endogenic, as we said, that the internal forces. What are the internal forces? Before we discuss each one alone, but we have to understand what is really the difference between the endogenic and the exogenic. Exogenic, something coming from outside and just maybe collision of a piece of rock that is coming from the outer space, nizak in Arabic, that came and collides with the this is something exogenic. But if I say earthquake, it's coming from inside, energy released from inside, then this would be endogenic. Let's study the endogenic forces, which means that the internal forces. Here, people, geologists, they call these endogenic forces, they call it constructive forces. What does constructive mean? Constructive means, in Arabic, بناء. It builds. These forces builds the shape of the earth. Scientists divided these constructive forces into two parts: fast process and slow process. So these forces, some of them are very fast and some of them are very slow. What are these fast processes? Earthquakes and volcanoes. Earthquakes and volcanoes are forces coming from the inside of the earth, and they are affecting the shape of the earth. If we have a volcano, the shape of the earth will change around this volcano. If we have an earthquake, the shape of the earth will change after this earthquake. But I here just want to remind you of something, that earthquake is part of this fast process, and it is, all of them are part of the constructive forces. How come I say that an earthquake is constructive? Is an earthquake constructive or destructive? Think of it. Is an earthquake constructive? Does it build or does it destroy? Destroy. So how come scientists put the earthquake under the name of constructive forces? Because scientists, geologists, they does not care for buildings, they care for the earth. So it is constructive in terms of the earth. The earth will change. If you have a volcano and lava comes on top of the earth, then it adds layers on top of the earth. So it is constructive in terms of earth, but it destroys building. This is another thing. This is what I want you to take care. Volcanoes and earthquake, they are destructive for buildings, but they are constructive for the shape of the earth, because the shape of the earth will change, the levels will increase or decrease, whatever, but it adds to the shape of the earth. So this you have to take into consideration. The other thing is these are fast process. What are the slow process? The slow process, isostatic equilibrium and plate tectonic. Isostatic equilibrium means some layers moving up or moving down. This may take millions of years. If you have a layer below the ground, and you will see in some lectures later that there are layers from very low depths, I mean very high depths below the ground, and now it is on top of the ground. How this happened? It happens during millions of years. It changed, it started to move gradually till it reached the top. So this is a slow process. Plate tectonic, the movement, how the earth splits into small plates and how these plates move, it takes a very long time to move. But between these plates, there may be a fast process for some energy released outside, causing an earthquake. So earthquakes and volcanoes are fast. Isostatic equilibrium and plate tectonics. Plate tectonics is the movement of the plates horizontally. Isostatic equilibrium is the moves of these plates vertically. So this is a slow process. The start of the geology. The start of the geology, there is somebody here called Alfred Wegener. They call him the father of geology or the father of plate tectonics because of what he proposed in 1915 till now. This is the base for what geologists use to describe the earth and how the earth was formed. So Alfred Wegener is the father of plate tectonics. He proposed his continental drift hypothesis in 1915. Continental means the continents, drift. It means that these continents were not Africa, Asia, Europe. They were not in the same places millions of years ago. They were in another places and they moved to reach this location. How did he prove this? I will show you and you will discuss, imagine the effort he has done to propose this. The continental drift hypothesis is a supercontinent called Pangaea. He said that before having all of these continents, they were just one continent. All of the earth was combined together in one continent. There was no Africa, Asia, no, they are all one continent called Pangaea that began to break apart 200 million years ago and form the present land masses and continents. So it was just one piece. It split it into smaller pieces to reach this shape of nowadays. This is the shape. Take a look. Start from here. This is the start. 200 million years ago. This was just one continent as this. You see here, this is just cracks showing Africa. This is Asia. This is North America, South America, and so on. So then, this is 225 million years ago. Of course, don't judge numbers. Numbers, you may look in another reference, you will find instead of 225, you will find it 200 only. Nobody was there to measure or to record. So this is just expectations. Then later, the shape change it to be this. And later, change it to be like this, then like this, and then like this. By the way, there is a verse in Quran. It says that وَإِنَّا لَمُوسِعُونَ. In the earth or the whole It's not only the Earth. All of these planets around us, the whole الكواكب كلها, they are moving with time and increasing in size. So when this was the size of the inhabited part of the Earth millions of years ago, now it changed because the whole sphere increased in size. This is another photo, but I think this is clearer for description. They are both the same, showing us what was happening. This is very good because if you can see, it has some sense. This is Africa, this is South America, this is North America. Africa here, it is bulging inside. South America is bulging outside, so it looks like a puzzle. You know the puzzle that we used to play with when we were small. It's like a puzzle. Something matches with another. You can put them together to reach a final shape. But you look here. What is here? This is very strange. This is India. India next to Africa. Is this possible? India next to Africa. India is in Asia. But where is Asia? Asia is the continuation of this continent here. This is Africa. This is India. This is Europe and Asia. Europe and Asia moved this way, and India moved this way, and they met together. So it means that India was not part of Asia. It was part of Africa. It splitted from Africa and drifted till it reached Asia and collided together. This is what we are going to... This, by the way, is very, very interesting to know this information, because when I come to something, I will show you that when you study what I'm saying, you will know how to judge information that you find on the net. Sometimes you find somebody sharing information. There is, maybe you will find someday somebody saying that India is not part of Asia, and it is a very interesting subject, so that he would take some likes and shares and something like this. But you have to be to understand really what is the truth, what information is correct and what information is false. So this is just a presentation. This was the shape of India 71 million years ago. Then it moved like this, like this, like this. Then it collided here with this shore of Asia. What happens if you have two things colliding together? Usually, if you have two cars colliding together, the strongest car will smash the weaker car. The weaker car will be diminished in shape, but the stronger will continue. So India was stronger. It just collided with this. India was stronger. Stronger. It collided with Asia. So Asia was a little bit compressed. When something is compressed horizontally, it expands vertically. That's why here you find the Himalaya mountains. It is the earth crust. It was thin earth crust, but after collision, it expanded vertically. So that's why you find here very high mountains compared to other locations. It is because of the tectonic movement. We will see something, but this is just an introduction. So, as an example of continental drift, it is India in Asia. So this is India and Asia. This is what you were speaking about now. Evidences of continental drift theory. Now he proposed a theory. Give us your evidence so that we can say that it is correct. He proposed 4 evidences. The first evidence is called the continental puzzle shape. If we put the continents together, it looks like a puzzle that pieces of this puzzle match together. This is Africa, this is South America. If you put Africa next to South America, it will fit like 2 pieces of puzzle. If you put North Africa with here, the north of Africa, North America with the north of Africa and Europe, you will find that it also fits in this part, and so on. So the first evidence he proposed is that all continents, if they are moved next to each other, they fit like a puzzle piece. So this alone, it is not an evidence, but this plus other evidence, it can be considered. What is the other? Matching fossils. You know what is fossils in Arabic? حفريات. So if I find something like مثلا the bones of a dinosaur that was there millions of years ago, it is in this location in Africa and it is in this location in South America. How come? The dinosaur is going to swim crossing the ocean? No. It means that one day these 2 parts were one part and the dinosaur just moved few steps. But when they splitted away from each other, some dinosaurs were there and some other dinosaurs were on the other side, and they perished and the bones were there, so it was there and here. So it means that matching fossils is a very good evidence. If you find, look at the shape of the Pangaea that he proposed. If you find that there is something here covering 2 continents and you can prove it in this location, how can he prove it? He must go. He had to travel to Africa, to South America, to North America, to everywhere to look for fossils. And you are not going to find fossils in the streets. You have to dig for fossils. So he traveled in many places and gathered as many fossils as he can find, and he compared these fossils together to prove this. So this is the next thing, matching fossils. Next thing is rock evidence, similar to fossils, the same type of rock. If I have a sandstone in Africa, say, and the same in South America, next to each other, it means that these were one day in the millions of years ago, they were just one piece of land and it just splitted into 2 pieces. The last thing is past climate data. He gathered some information related to climate, and he was able to prove that the climate at this location was the same as the climate at this location, and they both do not fit in the current location. Like finding something that is related to very cold areas near the equator. This is now very hot area. How come that I find that there are data saying that this area was very hot was very cold in the past. It is now 40 degrees centigrade, and this needs minus 1 or minus 2, below 0 degrees centigrade. So these are the 4 evidence. Let's study them one by one very quickly now. Puzzle shape. This is I think these two figures looks like pieces of puzzles matched together. So they don't need any more clarification. Matching fossils, the same. Look at this and look at this. By the way, these two figures are just the same, with minor differences. If I have fossils in this area, it means that the same fossils in Africa was found in South America. The same fossils in this part of Africa matched fossils in India, matches fossils in Antarctica, the South Pole. So or the North Pole, how come this happened? Similar to Australia and so on. So he went to these places, gathered data as much as he can, and he proved that here similar to here, similar to here, similar to here, similar to here, and so on. So this is a very good evidence. Rock evidence. Here are some mountains. These mountains, similar to it, are found here in UK. Similar to it is found in Scandinavia. The same type of mountain with the same formation and the same. So it means one day this was just one line touching each other, but then with time they drifted away from each other. This is something that needs you to know some background. You know what is glacial striations? In the North Pole and in Europe, there is snow. When snow starts to move, it moves very, very slowly. But when it moves, it leaves marks on the rock. It is hard enough so that it can, during movement, show some evidence that snow passed from this area, or glacial, just moved through this path. So if I find this near the equator in Africa, how come? How come snow or I have any glacial in this area? It means that one day Africa was at the north. It was not at this place. So, past climate data, he found at this location and at this location glacial striation. How come? This is the hottest part of Earth. It cannot come like this. It means that one day it was a little bit above or above or below, so that it would be in the cold zone. The opposite. He found bituminous coal, الفحم. You know what is الفحم? الفحم, it needs very hot temperature to be developed. So he found coal, bituminous coal, here and there. How come? I would expect to find bituminous coal here, not in the near the North and the South Pole. So if I find them there, it means that the shape of the Earth was completely different from what we see now. Let's continue. Wagner could not provide an explanation of exactly what made the continents move. So now Wagner, he managed to prove that they were one piece one day, but he could not present. He died. He passed away before having the time to prove that. So what is missing in the theory of Wagner is why the continents moved. It's just, it's not logic that I have a continent here and then after million years later I find it in another place. What is the reason for that? So he did not have the time to say this, but new technology helped in finding new theory called plate tectonics. I mean, what he presented was enough for us in the future to reach something called plate tectonics and study the movement of these. We will see one of these theories that describes the drift. According to plate tectonics theory, the uppermost mantle along with the overlaying crust behaves as a strong rigid layer known as the lithosphere. This is something that we've studied in the previous lecture. A plate is one of numerous rigid sections of the lithosphere that moves as a one unit over the material of the asthenosphere. We now know the layers from the previous lecture. So the continental drift theory, or the theory states that the upper part of the earth moves over the layers that is below, and by this movement continents drift away from each other. We will come to this is just introduction to what we are going to say. There is a theory called seafloor spreading theory. It was presented by Harry Hess. He presented something, it added to the theory of Wagner. So now both together we now can understand how to study plate tectonics very good. His theory that states that it's a geologic process in which tectonic plates, here the large slabs on top of the earth, split apart from each other. So the first thing is that this big plate splits into smaller plates. Seafloor spreading and other tectonic activity process are the result of the movement of the mantle convection currents. You remember from the other lecture, we said that there is something called convection currents. Let's see. You remember this figure? As I said, this figure is very, very, very good because it links many things together. This is the crust on top. So this crust on top, these parts may be splitted into smaller pieces, but if they split into smaller pieces, they will stay as it is. They are not going to move. What will cause the movement? Because I have here convection currents. These currents, this cooling system is moving. So if something is moving, it can move anything on top of it. So the parts on top of it, imagine if I decide which part can split, this part or this part or this part, the thinnest, of course, if something is going to split, the weaker is going to split. So we said that the crust at the continents at the ocean, oceanic crusts are very thin. So this is the thinnest part of the crust. So there will be a crack here. But if I have a crack here and I have convection currents moving here, these convection currents will result in pushing these two parts that splitted away from each other. And when they split away from each other, what will happen? Very hot material, molten material from below will come to fill this space. It's like, the eggshell. If you have an egg and you put it in to boil, and then suddenly it cracks, what will happen? The inside of the egg will come outside. You see this all of the time. This is exactly what is happening. You have a thin crust, a shell on top, and this shell is going to break for a reason, because it is under tension. It will going to break. Once it breaks, other material come outside and fills the gap. So that's why continents are drifting away, because if I go here, this is a continent here, and this is a continent here, and in between I have the thin crust of the sea or of the ocean. If it breaks at mid-ocean due to tension, then hot material from below will come to fill this space, and so on. So if I fill this space, what will happen? This continent and this continent will move away again from each other, and so on. So we are drifting each time away from each other. Continents are drifting away from each other. So this is what we mean here. This is another shape. This in the ocean. This is where the crack happens, and once this crack happens, because of what is happening in the lower mantle, these convection currents, it pushes this part away and pushes this part away from each other, and allow some of the material here from the outer core to come to fill this space, and so on. So there is something going. This is endogenic forces. This is coming from the inside of the earth. Very, very big forces. And sometimes these forces do not come very, very slowly. You may have some kind of very quick force coming, or very quick energy released away. And in this case, we would have a volcano, or we would have an earthquake. So this is what you have to understand. All of these are very, very good presentations for what I'm saying. Here is the crack. Of course, the crack, it should not cover the whole ocean. It may take parts of the ocean, here in one location, here in another location. What I want to show you is here, because this will link to another thing, what we said about the Himalaya before. When this very thin crust moves, what will happen? It will reach the continent here, but the continent is thick. So I have something thin colliding with something thick. So what will happen? The thick will stay in place, and the thin will go down. This is what is happening. This thin crust will go down, and the thick crust will stay in place, but because of the force of the collision, it will not be just thick, it will be thicker. The mountains will, the mountains will increase, the thickness will increase a little bit. And this is not all, no. Because of the force of the collision here, you see that, imagine two very big plates colliding with each other and moving relative to each other with very high friction. What will happen? Energy is going to be released. This energy will go on top, creating volcanoes. And once it creates volcanoes, what will happen? Lava, magma from outside, from inside of the earth, come outside in the shape of lava, and this lava covers the surface. It adds to the surface. Instead of having a thick surface, it is now thicker, because you are going to add on top of it some of the molten material coming from below. It will be outside, it will cool, and will be part of this sea, of this land, of this continent, and it will create more mountains. So that's why next to this phenomenon, you will find very high mountains, maybe volcanoes. It depends on what is happening below. Another shape summarizing all of the things together. This is the thin crust. This is the cracks that happen in the mid-ocean, and it moves like this colliding with the continental crusts, and once it collides, it goes down, and once it goes down, it melts with the hot, because layers below are very hot. So this oceanic crust will melt inside, and once it melts inside, what will happen? It will be part of this upper mantle or lower mantle, and then it goes again up and so on. So this is the cycle of the this is how the earth is cooled. Parts from outside come inside, loses lots of energy, and so it start losing this energy, and then going inside, meeting with the very hot earth below, and then coming or other parts coming to replace it, and these upper parts, once it goes up, it cools because the layers above are cool, and so on. There is a cycle taking millions of years so that this earth is shaped. So now you know how continents drifted away, how mountains emerged, how continents collided with each other, and so on. Plate tectonics. What is plate tectonics? They divided the earth into big major plates. Of course, there are many small plates, but these are the major plates. This is the African plateau or the African plate. So it is Africa plus part of the oceans around it. This is South American plate. Of course, this is South America plus part of the ocean around it, and so on. So these are the the plates that Wagner proposed. How many plates do we have? There are many plates. You can just you should know that there are 9 major plates: North America, Pacific, Euro-Asian, which means Europe and Asia together, Africa, Indo-Australian, Australian. Of course, you should not memorize these, but you should know that what are the names of them. So these are the plates. This is another shape showing us what we said before, that this is the crust of the earth. Here, the oceanic crust is very thin, that's why it cracks easily. This is the land where we have the thick continental crust. If 2 plates collided together, the thick will stay in place, and the thin will go below, and so on, for the cycles to continue. How plates move relative to each other. If I have, this is a plate, and this is another plate, what will happen relative to each other? Scientists divided the movement of the plates into 3 types: divergent, convergent, and transform fault. Divergent means that the plate is splitted and it moves away from each other. Convergent means that the plate is coming and colliding with another plate, and one plate is going down and the other is changing into a thicker plate because of the collision. By the way, if you look at a car that collided with the wall, you find that the car became thicker. Of course, it is now smaller because of the collision, but the thickness is more. So this is really a collision, similar to any collision that happened on the Earth. So it's divergent, convergent. Transform means one plate goes in one direction, the other goes in the other direction. These are the normal movement of plates relative to each other. These are the plates, and this is the expected movement of these plates. This is what is happening. If you look here, you will find that this plate is going right and this plate is going left. So with time, there should be cracks here, and this cracks allows the continent to move away from each other, and very hot material from below come to glue the parts together again, but for some time, then it breaks again and again, and so on, a cycle that is happening. So it means that here there is always motion. Here there is always motion. Let's see where is Japan. This is Japan. You see here next to Japan, there is also a boundary here. It means that earthquakes are related to the boundaries of the plates. If I am here in the middle of Africa, do you expect earthquakes to happen? Minimum earthquakes to happen. You here in Egypt, sometimes we have earthquake because we have a boundary a little bit close to us. But you always hear that the earthquake comes from Cyprus, because really, or comes from Turkey. You remember now that sometimes you tell you the earthquake coming from Turkey or coming from Cyprus, because really we are here, we don't have an edge for this plate, but there is an edge here that passes by Cyprus and Turkey. There is an edge here that passes next to Japan. So that's why in Japan every day you have earthquake, because this is very active place. So that's why this is a map. The yellow spots means the frequency of the earthquakes, and the red lines means the boundaries of the plates. You see that there is similarity. At the boundaries you have earthquakes. Here, as I just said, earthquakes are found in Turkey, Cyprus. Here, lots of earthquakes around all around Japan, from all directions. That's why if it does not come from the south, it will come from the north. It's any place around Japan, you find earthquakes. So this is how we understand earthquakes. This is exactly what we said about convergent boundaries, and we said that the model for convergent boundary is in India. This is India. This is the Himalayas, the mountains of Himalaya, and this is India. Once India came here, it collided with this plateau, and when it collided, it went below, creating the Himalaya mountains. So this is an example for convergent boundaries, Asia and India, the collision between them. And this is another description. I'm trying to gather as much photos, because in each photo you will find a good feature. So putting or studying the photos together, you will find something important. So here is the subducting oceanic lithosphere. Subducting, it means it is going down. It is the one that is the weaker that goes down. And here the continental crust, or the continental lithosphere, the same, that creates these mountains due to the molten material that comes out through the volcanic ashes from outside. This is very important, and I will later send you a link for something that will relate what you are studying to what you have heard, maybe you have heard before on the net. If you remember that sometimes, maybe 1 year ago, suddenly all of people are saying that Africa is splitting into two pieces. There was something, I will send you a link for a video for that. This video gathers the data that was shared with all people, that Africa, take care, Africa is splitting, as if this is something that they have discovered yesterday, and they are telling people, take care, Africa is splitting, you may tomorrow find that Africa is now Africa 1 and Africa 2 and so on. No, this was not the case. This information is known for geologists hundreds of years ago or decades ago. I don't say hundreds, maybe decades ago. It started with the Red Sea. The Red Sea is not really a sea. The Red Sea is a divergent boundary. That's why the Red Sea is very deep. You remember when they were speaking about building a bridge between Saudi Arabia and Egypt? It was not possible because you need to put supports in the sea. How come? This is very, very deep. You cannot put you may have a shallow river or a shallow sea and you can do many bridges. But here the distance is very big, so you cannot take it as one span, and in the same time it is moving with time. If you put a bridge, this bridge may fall one day because this width of the Red Sea increases with time. So you cannot put a bridge on top of it. This information, when you know it, you judge what you hear on the net. When you hear somebody some of our scientists saying that we are going to build a bridge between Saudi Arabia and Egypt, you tell them, no, you cannot do this. I know that before you say this is you are saying this for publicity only, but you cannot do something like this, because from geology we know that this is not stable area. To build a bridge, it should be stable from both sides. But if you have two sides moving away from each other, how can I put a bridge on top of it? This is one thing. How can I put a support in the middle of the sea that goes kilometers below the ground? I cannot do this. It is something for the time being, it is impossible. We cannot do this. So there is a drift here, divergent. They are moving away from each other, and it is continuing here, and it is continuing here. So it means that with time, maybe millions of years later, this will cause Africa really to split into two pieces. But sure, we are not going to see this because it will not be in our life. It will be, it needs millions of years to happen. If I go to one place here, say, or here, and I find that there is a gap, and yes, this is the start, but it needs lots of years to continue. So don't be drifted by the media and affected by the information. This is something we all know. As geologists know decades ago, and they know that it will happen, but later. Maybe somebody on the net read this information. He found that this is very good stuff for people to share, so he shared it, and people started sharing it. I will send you a link for a video. It's my video speaking about this, but it will be in Arabic because it was given for people in Arabic. Just describing what you have studied now related to what people say on the net. So this is important to understand. Motion in plate boundaries. This is a summary of what we have just said. It's not a new information, but it is also a very good shape of information. This is the mid-ocean ridge. This is where plates split. This is where subduction zone, it means that there is subduction, it means that the plate is going down. So this upper plate, because it is very thin, it goes down. This thick, it goes up. And because of the friction along this line, then there will be some kind of energy. It will be released in the form of volcanoes, and it may cause earthquakes for this area. This is another summary for the motion of the boundaries, but it is related to plate tectonics. This is exactly what we have said. We said that there is diversion, conversion, transform, where they move relative to each other, and this is what we mean by plate tectonics. It's the study of the motion of the plates relative to each other, either drifting away or colliding together or causing earthquakes and so on. This ends up our lecture for today. I think it was a little bit related to what we have studied so far. What we see so far, it will be linked to our lecture for earthquakes. So it is good that you understand it now, so that when we come to the lecture of the earthquakes, it would be very easy for you to understand. Thank you, and see you next lecture.